very practical to describe it this way. So let me give you a more practical description of this exact same thing. So let me give you that. And this will be what we use in practice to solve problems. So a practical definition. Really, this should be another theorem, but that's okay. So I'm still talking about that vector W. Oh, before I do that, so I think I said the word already, but let me write it down. We call W the stable vector. Or I guess maybe a stable vector, but it's fine. I said it was unique. So we call it the stable vector of the Markov chain. So that W is called the stable vector. I think I said that word out loud and didn't write it down, so I'll make sure I write it. Okay, let me give you a more practical definition now of the stable vector. And this is how we're going to actually be able to find the stable vector, because that's what we're going to be interested in doing, is finding the stable vector. Here's a sort of an equation that'll capture everything that we need. So the stable vector W satisfies the following equation. And it's a very simple equation. It just says that W times the transition matrix P is W again. So multiplying by the transition matrix does nothing for this vector. It just gives me back the stable vector. This is maybe one reason why we call this stable, because multiplying by the transition matrix doesn't do anything. In fancier math terms, I might call this a fixed point for the transition matrix, because it sort of fixes W. Yeah? Multiplying by P fixes W. Gets me W again. But I probably won't use that terminology. So we'll just say that multiplying by P does nothing for this stable vector. It's only for the stable vector, really, is what I want to say here. So in this definition, I'm defining W. This is like a property of W, not of P, right? Multiplying by P fixes W, like that. Gives me W back. So anyway, this equation here is what we need to know to be able to solve problems in this class. So we're going to translate this. Basically, what we're going to do is translate this into what we always translate things into in this class. We're going to translate it into a system of equations that we will then solve. So when I ask you a question like, find the stable vector, for some given Markov chain, our answer is going to be found by taking this equation and translating it into a system of equations somehow, and then solving it. And then that will tell us what the stable vector is. So our goal is going to be finding stable vectors, and that's how we're going to do it. Okay. Like 10 minutes left. I think I'm probably just going to cut it here today. And then tomorrow, I will start talking about consequences of this. So I will show us how we go about solving such a problem using this equation here and what I've talked about today. So let me stop here. If you guys haven't started taking a look at the activities yet, that's fine. Do so soon. And then tomorrow, I will talk more about stable vectors and how to find them. So if you guys have any questions, stick around. Otherwise, have a good day, and I'll see you tomorrow.